Hello and welcome to this Plastics training session. In this video, we will cover Module 1, Unit 1.3, Enzymatic hydrolysis, a green approach to separate waste streams for recycling. This module will describe and explain the underlying enzymatic process of unraveling cotton and polyester in textile waste. My name is Barbara Liedl and I'm a researcher and project manager at the TCKT. In Plastics, we're involved in various tasks, but mainly we're the leaders of the work package Chemical Recycling of Textiles through Enzymatic Reactions. We're demonstrating the recycling at small pilot scale in our facilities. A variety of different fibers is used to produce garments. In textiles, fibers are mixed to achieve specific properties, such as wearing comfort, crease resistance, drying properties, and so on. But the problem is, mixtures make recycling difficult. In Plastics, we aim to unravel cotton and polyester fibers in mixed cotton-polyester blends by utilization of enzymes to allow for real fiber-to-fiber recycling. The overall concept of recycling mixed textile waste starts at the textile waste collection. For our recycling method applied in Plastics, we sort out cotton-polyester mixed textiles and all other textile waste is rejected. Before continuing with the fabric, the metals and hard parts like buttons and zippers and so on have to be removed. At the same stage, the textile is shredded to smaller pieces and thereafter chemically pre-treated to enable the subsequent enzymatic hydrolysis. In this step, the cotton share is degraded to sugars, whereas the polyester fibers remain unchanged. They are filtered off and are going to plastics recycling. The sugar solution can be further processed in biochemical processes. In this module, we take a closer look at the enzymatic hydrolysis. The textiles we target in our process, polyester and cotton blends, are common mixtures for casual wear. Polyester, or more precisely polyethylene terephthalate, is a synthetic thermoplastic fiber that can be remelted in a mechanical recycling process. Cotton is of natural origin and mainly consists of cellulose, which in turn is made of glucose units. We separate these two different fibers with the help of enzymes, which are biochemical catalysts that specifically target the scission of the bonds in the cellulose chain and break it down to glucose molecules. Before the enzymatic hydrolysis is carried out, the fabrics have to be pre-treated. First, the fabrics have to be crushed to smaller pieces. Hard parts like buttons and zippers have to be separated, as they usually are of other materials than the fabric and can be a hindrance in recycling. And a chemical pretreatment is necessary to make the cotton fibers more susceptible to the later enzymatic degradation. In this so-called alkaline swelling, the shredded fabrics are soaked in a sodium hydroxide solution before the hydrolysis of the fibers is carried out. The enzymatic hydrolysis takes place in a heated vessel, where the fabrics are stirred at elevated temperatures in a buffer solution. Temperature and pH value are kept constant all over the reaction time of about 24 to 48 hours, depending on the composition of the input material. With the help of enzymes, so-called cellulases, the cellulose chains are degraded to sugars that are soluble in the aqueous reaction solution. The polyester fibers are not affected by the enzymes and can be filtered off after the reaction time. The separated polyester fibers are washed, carefully dried and further processed in a thermomechanical recycling process to granules with plastic processing machines. An additional step to improve polyester quality could be necessary. The sugar-containing solution is not thrown away either, but can be used as a feedstock for the production of, for example, bioethanol or biogas. The key messages to take away from this unit are that recycling textile waste is not easy due to the complexity of the materials and their combinations. Efficient separation technologies can help to unravel material mixtures and enable a recycling of the components. Such a low-energy technology is enzymatic hydrolysis. Its application can help to solve a so far unsolved issue of textile waste recycling. This concludes the Module 1. Coming up next in Module 2, Testing the Technologies, Unit 2.1, Demo Sites for Gasification and Chemical Post-Treatment, enabling innovation in circular plastic technologies. Thank you for watching this training video. Stay tuned for the next module, where we'll continue exploring innovative technologies for circular plastic value chains.